Hi students, today we're going to start learning about adding and subtracting polynomials. First, let's start with a warm-up from exponents, our last chapter. Go ahead and simplify this, and then we'll go over the answer together. Okay, our first step is to distribute this -7 exponent with the exponents inside the parentheses. So we would get w to the power of -14, k to the power of 0, -7 times 0 is 0, and p to the power of 35. Now it says to simplify using only positive exponents. So we need to write this as in the fraction form. So w to the -14 needs to go to the bottom of the fraction with a positive exponent. K to the power of 0, we know this is just 1, so I'm just going to put a big 1 through it. And p to the power of 35 goes on the numerator since that's a positive exponent. Okay, now let's start our new chapter on polynomials. So at the end of this lesson, you should be able to classify various polynomials. You should also be able to add or subtract monomials. So there are 4 different types of polynomials, and how I like to remember them is by their prefix. So monomial, just like the game Monopoly, has the same prefix as this game, mono. Mono meaning 1. So when you play Monopoly, there's usually just one winner. Binomial, I remember thinking about binoculars, and with binoculars there are 2 places where you put your eyes, so binomial means 2. Trinomial, I think of a tricycle, which has 3 wheels, and polynomials, like polygons, have any number of sides, so usually they have 3 or more sides to them. Okay, so we're going to talk about the number of terms. We'll give an example, and we'll talk about the degree of each of these types of polynomials. So for a monomial, that means there is 1 term. An example would be 78b. That's 1 term. Everything is together here. And the degree, we look at the degree of the exponent, the highest exponent. Here, b is the variable here. The exponent on it would just be a 1, which is invisible there. A binomial has 2 terms. An example would be 3x plus 1. Notice that the plus sign separates the 2 terms here. And the degree, so looking at the variable x, its degree, or its exponent, is a 1. So it also has a degree of 1. Trinomial, this means there are 3 terms. So an example could be something like this, x squared plus 2x minus 1. The degree, so look at the exponent with the highest number, x squared, so the degree would be 2. And lastly, a polynomial means 3 or more terms. So an example could be x to the 6th minus 2x to the 3rd plus 4x plus 3. So here there are 1, 2, 3, 4 terms, all separated with plus or minus signs. The degree, so we need to look at the variable with the highest exponent. In this case, it's 6. So the degree is 6. What is not a polynomial? A polynomial, it can't be a polynomial if it has a negative exponent. Okay, let's do a few examples. So, is the following a polynomial? If so, find its degree. So the first one, yes, this is a polynomial. It looks like it's a monomial because it's all stuck together here. There are no plus or minus signs. And it has a degree of 8 because 8 is the highest exponent. Looking at example 2. So example 2, yes, this is a polynomial. It's a trinomial because there are 3 terms. And the degree is 2 because that is the highest exponent here. Example 3 is a little tricky. We see a fraction here, and this fraction can actually be written as a negative exponent like we learned in the last chapter. So this right here could actually be written as 3x to the -1. And in this case, anytime we see a negative exponent, then no, this is not a polynomial. And lastly, looking at example 4, yes, this is a polynomial. There are no negative exponents here. There are 4 terms, so it is a polynomial. And the highest degree looks like 2. Okay, let's continue on with adding and subtracting. So in this example, we need to add these 2 polynomials, or these 2 binomials here. So grouping them together, I'm going to rewrite this as 5m squared plus 3m squared, because these are like terms. And then I'm going to write plus 9 and plus 6 next to each other, because those are like terms. Sometimes it's easier seeing them grouped this way. Go ahead and add the like terms. So 5 plus 3 is 8. And we leave m squared how it is. Notice you don't add the exponents here. You just leave it. And then 9 plus 6 is 15. So our final answer is 8m squared plus 15. Now looking at example 6, in this case we need to subtract these 2 trinomials. With subtraction, we actually need to distribute this negative sign first and then combine the like terms. It's a little different than when it has a plus sign between. So let's rewrite it. 7a to the third minus a plus 3a squared. That's the first trinomial. Now distributing this negative sign. We have negative 8a squared plus 3a, because a negative times negative is positive, and plus 4. Okay, let's go ahead and rewrite this with like terms together. So 7a to the third, this can go first. There are no other a to thirds here, so that one is done. And then we can combine the 3a squared minus 8a squared. So when we combine these, 3 minus 8 is negative 5a squared. And next, let's go ahead and look at the negative a and the positive 3a. So this is a negative 1. So let me put the 1 here so we remember it. Negative 1 plus 3. So that would be positive 2a. And lastly, this 4 can just be put on the very end of this expression. And this would be our final answer. Notice when we write it, we always write it in descending exponents here, so it's highest to lowest. Okay, students, you guys go ahead and try these 3 problems, and then I'll see you tomorrow.